Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video. If we look here on the screen, we are going to be referring to the interior and exterior angles of polygons, starting with triangles and moving on up from there. In this video, we will go over first what is called the triangle angle sum theorem. We'll do that very quickly. And then the polygon angle sum theorem. We'll do some examples on that. And the remote exterior angle theorem. One at a time. Check them off as we go. Let's move forward. Let's start just with this basic conceit here, guys. The sum of the three interior angles of any triangle is always 180 degrees. When I add this angle measure with this one, it'll always be 180 no matter what they are. Or they have to be, otherwise it wouldn't be a triangle. And I have proof. I have proof of this over here. So let's say that we had three angles right here. 1, 2, and 3. Now this is a linear trio, not a linear pair, but a linear trio, and I think you should agree, because they form to make a straight angle and adjacent, that these indeed would add to make 180 degrees as well. Now, what does that have to do with triangles? Well, let's make a triangle out of the information that we have here by me drawing right here a parallel line right here to this information. So if this is parallel to this, guess what we have, guys? Take a look. Oh, transversal with two parallel lines. You know what we have here? Alternate interior angles. If this is one, this is one. And over here, what do we have? Oh, two parallel lines cut by another transversal. You see that 3 right there? It has another alternate interior angle right there. And when two parallel lines are cut by a transversal, it is indisputable, guys. That should also then be a 3. So you know what I have? 1 plus 2 plus 3 is 180. 1 plus 2 plus 3 is 180. Do you guys see that triangle there? The golden triangle. Yes, indeedy. Now, they might be in different order, in different areas as here, but they still add to 180. And that is proof. Coincidence? I think not. All right, anyway. Let's move on. So if they add to 180 degrees, just make sure you kind of have that idea. And that's a very quick look at the triangle angle sum theorem, guys. They add to 180 degrees. Now, why is that important for our future polygons? Well, let's take a look. First, my face is going to get all over the place here, guys, but it's just there's another diagram right there. Let's take a look at polygons as far as bullet points. Some of these I will not even talk about or use, but they're here for you if you want to see them. A polygon, by definition, guys, we have an enclosed 2D shape. It can look like this or this, but it has sides and angles that are equal. I have a 5-sided shape and a 5-angled shape, a 4-sided shape and a 4-angled shape. 1, 2, 3, 4. Angles can be concave like you see here, or we can get a convex angle like that. It's still a polygon. Circles are not polygons though, right? They don't have sides or angles, okay? So kind of just keep that in mind. And I will also be referring to these things called diagonals, guys. A diagonal is something like this, going to non-adjacent vertices from here to here. That's a diagonal. Or from here to here is a diagonal, something like that. Okay, those are diagonals. And what I'm going to do, guys, is I'm going to draw triangles within diagonals and kind of show what the interior angle sum is of polygons. So let's take a look at the interior angles of a polygon. Knowing that the sum of the interior angles of a triangle is always 180 degrees, can we discover what the sum of the interior angles is of any polygon? Well, we can, yes. Let's check it out. A 3-sided shape has a 180 degree interior angle sum. I'm going to actually here, there is a polygon there, a pentagon there, but I'm going to go ahead and do a rectangle next and just kind of draw within here. What if I draw a diagonal across here, guys? Take a look at this. I have a triangle right here that these 3 angles added together is 180, and then these 3 angles added here together is 180, because 2 different triangles both add to 180. The whole interior angle sum of that, therefore, is 180 plus 180. So a 4-sided shape, guys, has an interior angle sum of 360 degrees. Now, a 5-sided shape, let me break this up a little bit more for you. Let me draw a couple more triangles within here, only divided by interior angles. So if I did a diagonal right here, I just made a triangle of these 3 adding up to 180 degrees right there. And if I did another triangle right here, now I have 3 triangles within here. One triangle 180, this triangle here has interior angles that add to 180, and then this one right here is a triangle that adds to 180 interior angle sum, right? They all do. 180 plus 180 plus 180 is 540. You might be able to make a conjecture on what happens next here. There is a difference of 180 here, and if I keep adding 180, it's true, you'll keep getting, if I add another triangle to this thing basically, here's another triangle, now it's a 6-sided shape. 1, 2, 3, 4, 5, 6. And this is 180 as well, and that's 720, and we keep adding there. 900, 1080, 1260, 1440, and so on. 1260 and 1440. Now, this is also, 180 is also, guys, it's also 180 times 1. 360 is 180 times 2. And I can keep writing this list, but what's happening here, this number, that 2, that 3, this 4 right here, this would be how many triangles you'd end up seeing in the list, right? We saw this hexagon right here as 1, 2, 3, 4 triangles, and triangle interior angle sum is 180. The pentagon only had 3 triangles here. So what we're going to do is try and come up with, based on the number of sides, try and determine what the interior angle sum would be based on knowing how many triangles there would be. Notice how a 3-sided shape only has 1 triangle in it. Duh, it's a 3-sided shape. A 4-sided shape had 2 triangles. Remember the rectangle has 2 triangles here? The pentagon 5-sided shape has 3 triangles there. The 6-sided shape has 4. There are 2 less triangles than there are sides in these shapes. And this continues forward. I'm going to do it a couple more times here. But the bottom line is, guys, if n was the number of sides, if n is the number of sides of your shape, you can determine the interior angle sum formula. If this is n, you can determine the interior angle sum d by taking 180 and multiplying it by n minus 2. There are 2 less triangles than there are sides, and I'm going to use this formula here. D equals 180 times n minus 2 to get the interior angle sum of an n-sided shape. So let's look at some examples together here. Use the angle relationships in each of the diagrams below to solve for the given variables. Let's look at part A, and I'm going to rewrite this one more time. D equals 180 times n minus 2. Let's figure out what m is based on looking at, this is a 1, 2, 3, 4, 5, 6, 7-sided shape right here. A 7-sided shape actually has 5 triangles in it. Whether or not you want to draw them, that's not the end goal that we're going to do here. But what we are going to do is figure out what the interior angle sum of a 7-sided shape is by doing 180 times 7 minus 2. 7 minus 2 is 5. You could get the calculator out. I'll help you with this one here. That should be 900. So the interior angle sum of this 7-sided shape, and by the way, it doesn't have to be all angles congruent or anything like that, is 900 degrees. That means when I add up all of these, it will equal 900. And that's exactly what I'm going to do. So as you can see right here, I added up every angle and set it equal to 900. I just put parentheses to make sure that you knew which parts were which angles. Now I'm going to combine like terms here just to make it faster. Combine all the m's and the constants. Okay, and here's when we add them all up. I decided to use purple just to make sure it's distinguished. And then let's subtract 501. And then let's divide by 3. M equals 133. There's the result. So let's try this with B now. Okay, the first part is let's figure out the interior angle sum of a 1, 2, 3, 4, 5, 6-sided shape. So 180 times 6 minus 2 is 180 times 4. Remember, that does mean that there are 4 triangles inside the hexagon, and that's 720. So this is a 720 degree interior angle sum inside here. There are 6 x's that are adding together here, x plus x plus x, or 6x equals 720, 720, and divide by 6, we'll get x equals 120. That is the measure of each interior angle in the polygon there. Okay, part C gets a little tricky, so let me open it up for you by starting and saying, in an isosceles triangle right here, as they're marked congruent, that means these base angles will also be congruent right here. They're unknowns right now, but as we know, the interior angle sum of a triangle is indeed 180. So you could solve for just the unknown x's here just to begin with. That could work out. 64 plus 2x is 180, and then that's 116, so x is 58. So now that we know that these two things are 58 right here, we have to figure out what k is in the end, and I think the reason that it helped is because now we can just look at this 1, 2, 3, 4, 5-sided shape, this pentagon, and figure it out by knowing what this is because it's supplementary with 58. Well, if this is 58 right here, guys, then this one right here is going to be 122. And this one's 90 because it's a right angle. So try and add these ones up set it equal to, oh, what's its interior angle sum? Let's find out. This interior angle sum is 180 times 5 minus 2, which is 180 times 3, which is 540. You know, if you have use of this table, you can also use this as well. There's the 540. Maybe at some point you just kind of use that if you have it. All right, so what equals 540? Well, all these added together do. So all these added up equal 540. Let's start getting k by itself. So combined like terms, we get 396. And if you subtract 396 from both sides, we'll end up getting k equals 144. And that is the unknown measure there. All right, part D, let's do one more here. I do see parallel lines, and we don't have the measures of these two angles, you know, right here. But you know what we do know is this is two parallel lines cut by a transversal. If you notice, these are same side interior angles. I don't know if you know, but same side interior angles are supplementary. That means these two together, whatever they are, they add to 180 degrees. So let's try and solve the rest based on that. 180 is those two angles plus 135 plus 2y plus 3y. This is another 1, 2, 3, 4, 5-sided shape, and a 5-sided shape adds to 540 degrees there. 2y plus 3y is 5y, 180 plus 135 is 315. And let's solve the rest of the way by subtracting and then dividing. So we get 45 degrees, or 45 right there for y. And that is how we use the polygon angle sum theorem that states, once again, the interior angle sum is going to be 180 times the number of triangles that appear, which is always 2 less than the number of sides that you have. We use that to start off with, and then some other properties. Okay, so far we've covered the triangle angle sum theorem and the polygon angle sum theorem. Now let's do the remote exterior angle theorem. And this one is a little less necessary, but I'll show you the redundancy outside of it if we don't. First of all, an exterior angle, it's the mentions up here. I'm just going to say it right now. An exterior angle is an outside angle. If these are inner angles, outer angles, though, it's not the entire thing right here. It's just an angle formed after you would extend a line from one of the sides of your shape. So 4 is an exterior angle to 3. They always form a linear pair with the inside thing. I could make another exterior angle here with 1 and with 2, and those would be exterior angles. But here's just one of them. Remote exterior angle is, say, 4 is a remote exterior angle to 1 and 2. Remote meaning distant. It is far away from it. And the remote exterior angle theorem states that this exterior angle here equals the sum of the other two exterior angles. Okay, very quick proof on this one. We know that the measures of the interior angles of a triangle all add to 180 degrees. We also know that 3 and 4 are supplementary, so they also add to 180 degrees. If both of these add to 180 degrees, then we could also set them equal to each other. That's the transitive property of equality at play there. And the coup de grace last step is measure of angle 3's on both sides. You subtract it from both sides, they cancel out. Basically, I'm saving you from steps of saying, what is the measure of angle 3 if I find these two, subtract them from 180, and then I subtract that number from 180 to figure out angle 4. You're doing the same thing twice, and you don't really need to do it. You can save yourself some steps. You just gotta recognize that it's happening. So let's do 3 final examples, and then it's quitting time here. The very first example here, let's find out what W is by knowing 70 and 50. W is a remote exterior angle to 70 and 50. Therefore, W is just the sum of 70 and 50. W is 120 degrees. And again, we're saving the step of figuring out that this was 60 degrees by taking away from 180 and then taking this away from 180 and all that kind of stuff. It's too much to need to do. Remote exterior angle takes care of that. All right, the next one right here, we know that the remote exterior angle is 110 by adding these two together, but we still have to find out the y right here. So we subtract 80 from both sides and we get y equals 30 degrees. Pretty straightforward. Okay, and then the last one, 3x plus 2 is this guy, just so you know, and then there's the 55, and then here's the remote exterior angle. So let's add these two to set it equal to that and solve for x. So here's the setup right here as you add those two, and it equals, again, the remote exterior angle. And then as we solve for x here, we get 3x plus 57 equals 13x minus 3. Subtract the 3x, add the 3, and you get x equals 6. Now, if I asked you to then find the measure of angle FAB, that's this thing right here. That's this one, FAB. You substitute 6 into here. 13 times 6 minus 3 equals 78 minus 3, which is 75 degrees. And that's it, and that's all. So, as we check off everything that we've done here, we have determined how to find the interior angle sum of triangles using the triangle angle sum theorem, and the interior angle of any polygon by using the polygon angle sum theorem, and finally the remote exterior angle theorem. It just kind of speeds things up. It's not a required knowledge if you know the triangle angle sum theorem, but it really speeds things up and takes the redundancy. So that ought to do it for me. Mr. Robinson here. Thank you for watching. Take care.